Hello everyone. Today let us learn how to use an I2C LCD screen and how to show fixed messages onto I2C LCD screen. So LCD screens can be used to display messages. These are small panels, normally around 2 rows in dimension and around 16 characters each on each row. Uh, I have just searched for LCD and you can see there are two LCDs screens over here. One is a normal LCD into two, that is 16 characters into 2 rows. This is this one. But we are not going to use this one. We are going to use the I2C one. Okay. It is simpler to use as you can see from both the things. Both the screens are almost similar except for the fact that the I2C one has only 4 pins to connect, whereas the other normal LCD 16 by 2 has quite a number of pins to connect. So we will do the other one also, yes, but at the moment we are going to use the I2C one. Okay, now first things first, let's see the code. Let's remove everything from here. First thing that we need to do is to include a library, and the library is called as LiquidCrystal I2C.h. So I'll give the command hash include in angular brackets LiquidCrystal underscore I2C.h. The next thing is we need to create an object of this kind. For example, if you just see the servo thing when we when we used the servo motor, we included a header file, right? We included servo.h. And today we are going to use liquid crystal. So we need to create an object of liquid crystal also. So how do we create? So we use the same liquid crystal. This is the name of the class, and we'll call it LCD. Okay, the name of the object is LCD, and you need to supply it two things. Number one is the base address, and the base address is normally 0x27. It is a hexadecimal number 27. So all hexadecimal numbers in C++ or even in Java, they start with 0x. So any number you start with 0x is actually a hexadecimal number. You need to specify how many characters are there in each row and how many rows are there. So basic idea is this. So not a big deal. So this is how you create an object. The name of the object is LCD. Okay. Its base address is 0x27, which is normally there. 99% of the time, this is the one. And how to find it and how to change it, we'll do it sometime. But normally, this is the thing that you need. Next, we will start off with this void setup function. And in the setup function, we are going to do, first of all, going to initialize the LCD monitor, LCD screen. So for that, we will use the init function. So that is called as lcd.init function, and we are going to turn on the backlight of the LCD. So we'll say lcd.backlight function. Okay. Alright, so this is basically used to initialize so that it starts working, just like the begin command of the serial thing. And this is to switch the backlight on. Next, we need to start with the loop thing, and in the loop, we are going to first thing first, we need to make sure that the system is ready. So we are going to wait for the system to get ready, and we'll give a delay of 1000 milliseconds so that next you know that this LCD has two rows, and I want to display two rows on that. Okay, for example, welcome from in one line, and in the second line we'll say RS Quora, right? So these are the two lines that we are going to display. So what we are going to tell the computer first is I want to bring my cursor. For example, even if you are working on Microsoft Word, when you are typing stuff, the stuff gets typed at the cursor position. So if you need to type it somewhere else, you need to bring the cursor over there. So here also we will use a setCursor function to tell the computer, okay, move the cursor there. So setCursor function is written like this, and we write 0 comma 0. That means we are basically specifying which column I'm specifying which column and which row we are going to write. And how do we write? We just give a print command. We say lcd.print, and we write in as a string. I write welcome from, this is my first line now. Now, because this in the I want to display RS Quora in the second row, my lcd.setCursor changes now. How does it change? I say 0 comma 1. That means I want to write whatever I'm going to write. It is going to be written in at the first character, as on the first character position, starting from the first character position, going on the second row. Second row is naturally row number 1. Okay, so I'll say lcd dot print in brackets in double quotes rsqour. All right, simple thing, not a big deal. All right. So now let us do the connections now. The connections, let us understand. It has basically 4 pins, and the 4 pins are going to be connected. Say ground gets connected to ground. Let's connect it on that side of ground. Let's not have too much of a network of wires. VCC, we don't have VCC on this side, so we'll put it VCC on the other side now. So we'll put it on to 5 volts. Okay, this monitor, this screen could be connected to the 3.3 also, but we will be connecting it to 5 volts. Okay, this is going to be red. It is. Alright, now the SDA and SCL pins, they are always connected to, they are always connected to A4 and A5 pins. So we will connect SDA to pin A4. Right, let's color this. And the SCL pin gets connected to A5. So this is the connection that we do. That's all. So that means the ground is connected to ground, VCC to positive 5 volts, SDA always to A4, not to anything else, and SCL always to A5, nothing else. Let us now see how things work. Start the simulation. Alright, yes, there is a problem. I spelled this incorrectly. Let's start the simulation again. And nothing has happened. Let's see what went wrong. Uh, it has, let us check what the specifications say. Okay, now the base address of this particular LCD is given as 020, not 027. Let's change that to 027. The physical ones that you buy from the market, they always have that 027 as the base. Second thing is we need to change the type of the LCD to PCF based. Let's now run the program and see how things happen. All right. So it has displayed. Okay. Now, if I wanted it to maybe switch on or off, maybe something like that, so I could just blank it. Okay. So to blank the particular screen, we have a function called lcd.clear. So the function can be written as lc.clear, but before clearing it, I need to delay it because I want to see it also. So maybe I'll give a 1 second delay. So what happens now? After a delay of 1 second, it is going to clear the LCD, and when it goes back into the loop, it displays welcome from RS4 again. So let's see how things happen. So it displays welcome from RS4, blanks it, again displays, blanks it, again displays. Alright, so we have learned that the some commands basically associated with the I2C LCD. Okay? So we are working on I2C LCD. So how do we do it? This statement is not required. Okay, how do we do it? We basically use LCD_crystal underscore I2C.h. You can see from here. You can need to create an object just like a variable, but we need to supply it three arguments. One is the base address. You can go and check the specifications here and figure out what is the base address. If the base address is 20, for example, then I need to change this also to 20. So then only it will work. Okay. In the setup function, we need to initialize and we need to switch on the backlight. Now, in the loop function, we need to delay it for 1 second so that the system is ready. Then we need to set the cursor to 0, 0. That means 0 column, 0 row. That means top left. And then lc.print will actually display it at that location from 0, 0. Then we need to change the cursor to 0, 1. That means 0 column, but row number 1. That is the second row. And I print. So this will be printed on the second row. After a delay of 1 second, I have cleared it. So that means it will clear the screen. And after 1 second, it displays the screen again. Okay, that is all for today. I think we have learned a little bit about the LCD. In the next video, we are going to learn a little about more functions that could be used with LCD one I2C. Thank you for watching. See you in the next video.